Okay, I hear the recording in progress. Okay, we're down to our last section, 4.9. We have plenty of time to do that. So most likely I'll finish early, as I said, today and tomorrow and Thursday, in which case you can ask me questions. And if you don't have any questions, we can just adjourn for the day. And when I take a question, I can take questions from anything in chapter 4 if you wish. Okay, so reminder, our next exam is Friday, covering all of chapter 4. It's our largest chapter. We do have 3 more exams left and a final exam, but they're much smaller. Chapter 5 is very small. Chapter 6 is not that long either. Okay. So we have exam 4 Friday. 2 Fridays after that, the 19th is our next test. It's not that long. We have a lot of holidays in November. There's a Veterans Day, there's Thanksgiving, and so on. So we're ending very soon. Okay. I'm not quite sure if we're going to have the last exam on Thursday the 9th, but we'll see. Okay. Because I'm not sure I can get you back to test right away, but again, you don't really need that last test. Even if I don't give it back to you by the day of the final exam, you have the solution. I'll make the solution video based off of that. Okay, and final exam is Monday the 13th of December, 8:10 to 10:40. So please make a note of that. Okay, and a reminder for the final exam, you're allowed 6 formula sheets. Why don't you just bring in the formula sheet from the first test and the second test and the third test, and you're making the 4th test now and 5 and 6, so you don't have to reinvent the wheel. You don't have to make up a brand new set of formula sheets. Just bring whatever you had for the previous formula sheets to the final exam, and then you're good. Okay. And if you want to go back and add stuff, you can. So like maybe after the second test, you said, "Oh, I wish I put this thing in." You can do it. You can still do that even now and put more stuff in your formula sheets if you wish. Okay. Okay, so let's continue on with some problems. And again, we'll more than likely finish somewhat early, and then I'll let you ask questions. So key ideas again are law of sines and law of cosines. So law of sines on page 264, put this on your cheat sheet. Sine of alpha over A equals sine of beta over B equals sine of gamma over C. A is opposite alpha, B is opposite beta, C is opposite gamma. And little a is opposite big A, little b opposite big B, little c opposite big C. Law of cosines, there are 3 varieties. To me, you only need one. A squared equals b squared plus c squared minus 2bc cosine of alpha. These are equivalent. You just kind of change the letters around, and it's the same idea we have there. Okay. Okay, 4.9, page 271, number 9. So what did they give us? So that alpha is 130 degrees, B is 5, C is 7. Alpha 130, B is 5, C is 7. Okay, here's a good example where they give you exactly one of each letter. Normally they give you 3 pieces of information between A, B, and C. Alpha is like A, B, and C. So if they give you exactly one of each piece of information, well, unless they give you 2 angles. If they give you 2 angles, you can figure out the third, right? But something like this, you have to use law of cosines. Law of sines won't work because if you try to set it up, you won't be able to cross multiply it and get what you need. Okay? So this is going to be law of cosines. All right, so ignore the red. Red is derived stuff, but given stuff. Alpha is 130 degrees, B is 5, C is 7. Okay. So I have one of each letter. So if you try to set up law of sines, it wouldn't work. So I use law of cosine. So that's going to be A squared equals B squared plus C squared minus 2BC cosine of alpha. Okay, so plug in. So B is 5, C is 7, minus 2BC, 2 times 5 times 7, cosine of 130 degrees. And punch it in the machine at 119. Let me try to verify that for you. Oh, I got to make sure I'm in the right mode. I just taught calculus and they were in radians. So I got to switch to degrees. Okay, so I'm back in degrees now. Okay, so this mess here. So 5 squared you could put 25, I know, and 7 squared, I know that's 49, but if you're too lazy to do that, just type it in. Minus 2 times 5 times 7 times cosine of 130. Okay, 118.995, call it 119. That's a squared. Hit my square root button. And 10.91. Okay, 10.91. Now that I have that, I can switch over to law of sines. Okay, sine of 130 over 10.91 equals sine of beta over 5 equals sine of gamma over 7. Okay, if I did not have that 10.91, okay, this would have been just little a, right? There's no way I can cross multiply to get what I needed, okay, because you have exactly one letter of each. Okay, so if I cross multiply here, you got a beta and a gamma. If I cross multiply here, you would have a beta and an a. If I cross multiply here and here, you'd have an a and a gamma. So you have two variables, so there's no way to do it. But now that I have one a and alpha, I can go from there. Okay, so cross multiply here. 5 sine of 130 equals 10.91 sine of beta. Divide both sides by 10.91. Get 0.3511. So 5 sine of the answer. Oops. 5 sine 130 divided by the answer that I got. 0.3511. That's not beta, that's sine of beta. Okay. So I want to go inverse sine. So inverse sine, second function, inverse sine of my answer. Okay. It's nice if you have an answer button, stores the last answer that you have. So when I hit inverse sine of answer, it's just like to the machine, inverse sine of 0.3511 to blah, 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 if I can read it here, all that. 20.56 degrees or something like that.
Right. Do you always want us to round to 2 decimal places?
Well, I was much around to 2 decimal places. I don't really have a hard and fast rule, but in this case, you can.
So if we round to 1, it's fine.
Round to 1, it's fine. It's likely that your answer will be less accurate, though, if you carry that inaccuracy throughout. But I'll let it go. Okay. And then once you have 2 angles, don't do any more trig. You could switch to law of sines. You could switch to law of cosines, but why do that? You know that these 3 have to add up to 180, right? So once you have 130 and 20.56, then just go 180 minus. So I did 180 minus 130 minus 20.56. That's the easiest. Why do any more trig when you don't have to? So 29.44. Okay, so now the triangle is solved. I've completely solved the triangle. And what does it mean to solve the triangle? Find all 3 sides and all 3 angles. Usually they give you 3. All right, so here we are. One other thing to note, and this is going to involve a problem later on. Sine of beta is 0.3511. There could be a second quadrant angle that makes that true also. Remember, this means y coordinate. Y coordinate is 0.3511, so we can digress and show you something like this. The y coordinate is 0.3511. There's an angle here, but there's also an angle here that you may have to consider. Now, in this particular case, I know I don't have to worry about it because I know one of the angles is already 130. Okay, so if one of the angles is 130, I can't have a second quadrant angle that's going to be more than 90. And 130 plus 90 is already past my quota of 180. Right? That will come into play, however, in one of the problems that we will do probably tomorrow. Okay, where you actually have to consider what happens if the sine of the angle is a first and a second quadrant angle, in which case you'd have 2 possible triangles, and that actually shows up. Okay, but in this particular case, we don't have to worry about it because sine of beta is 0.3511. If I pick a second quadrant angle, that means it's more than 90. but 130 plus 90 is what, 220 something? That's already past my allotment of 180 degrees, so I don't have to worry about it. Okay, so bottom line, this triangle is solved. I now have all three sides. Let's see, 5, 7, and 10.91. I have all three angles, 130, 29.44, and 20.56. And a double check, largest angle and largest side. That's correct. Smallest angle, let's see, it looks like that one. And the smallest side is 5. Yes, that's correct. So, by the way, that's not a guarantee that you did it correctly, but you know, 10.91, if this came out to be 15, I wouldn't be able to tell the difference. But, you know, it does seem reasonable that we have the right answer. Okay. All right, next one I want to show you is if they give me just 3 sides. Number 11. 8, 9, and 13. That's all we got. So you have all 3 sides. Ignore the red. It's just 3 sides, 8, 9, and 13. What are the 3 angles? Okay, so again, please notice if they give me the 3 sides, law of sines is hopeless. Because even though I can put down the 8, 9, and 13, I don't know anything else to get going, right? So suppose I put 8, 9, and 13, right? I can't cross multiply because however I cross multiply, I'll have 2 variables, right? Like if I try to do this, if I cross multiply, I'll have alpha and beta. That's no good. If I try to do these 2, I'll have beta and gamma. That's no good. If I try to do the 2 extremes, I'd have alpha and gamma, and that's no good. Right? So I'd be stuck. All right. So law of cosines. You actually have 3 choices. Okay. The suggestion, the best way to do this is always aim for the largest angle first. And I'll tell you why in just a second. Okay. So which one will have the largest angle? Well, it's opposite the largest side, which is 13. So I should do that one first. Okay, so I'm using c squared equals a squared plus b squared minus 2ab cosine gamma. Okay, so 13 goes there, 13 squared equals 8 squared plus 9 squared minus 2 times 8 times 9 cosine gamma. Plug in stuff. 13 squared is 169, 8 squared is 64, 9 squared is 81, 2 times 8 times 9 is 144. Subtract 64 and 81. So 164 minus 64 minus 81 is 24. Divide both sides by negative 144. Cosine of gamma is negative 1/6. It's okay to be negative. It means you're going to get a second quadrant angle. Okay. So where is the cosine negative in quadrants 2 and 3? For an angle in a triangle, it would be second quadrant. So I want inverse cosine of negative 1/6. It looks like it's 99.59. Evidently, let me try it again. Inverse cosine of negative 1 divided by 6. Inverse cosine, negative 1/6, 99.59 degrees, roughly. And now that I have that, I switch over to law of sines. I could go back and do law of cosines, but it's much longer and harder. Law of sines is much easier. Now I can go sine alpha over 8, sine beta over 9, sine gamma, which I now know to be 99.59 over 13. Before it was alpha, beta, gamma, right? And then cross multiplying wouldn't help because if you cross multiply, you still have 2 letters between alpha and beta, gamma somewhere. Okay, so I'll cross multiply right here. That times that equals that times that. So 13 sine beta equals 9 sine of 99.59 divided by 13. Sine beta is that, which evidently comes out to be 0.6826. Let me see if I can show that to you. 9 sine of 99.59, which I'm just going to put as answer, divided by 13. 0.6826 or whatever. Oops. did it wrong. 9. Sorry, I typed in 8. 9 sine 99.59 divided by 13. Okay, 0.6826. So I do inverse sine now of my answer, 43.05 degrees. And now, here's why you aim for the largest angle. If you aim for the largest angle, when I hit inverse sine, I got my second quadrant, my first quadrant angle, 43.05. But there's another angle in the second quadrant for which the sine of that angle is point whatever that we said, 0.6826. But since I already have the largest angle, I already got the largest angle, I cannot have another angle greater than 90 degrees. Okay. So that's the reason why, in general, when you get a situation like this, aim for the largest angle first. Then you don't have to worry about doing this, finding a second quadrant angle. So I got beta is 43.05. I now have two angles. Yes, I could do law of sine to get the third, but why do that? It's much easier to just go 180 minus the sum. So alpha is 180 minus the other two angles, which are 43.05 and 99.59. It comes out to be 37.36. So here we are, the triangle solved. Well, I already had all three sides, but now the three angles are 37.36 degrees, 43.05, and 99.59. Okay, so it looks like this now. 37.36, 43.05, 99.59. And double check, largest angle, largest side, opposite. That's correct. And is smallest with smallest. Smallest angle, smallest side, yes. So that's kind of verified. Okay. Okay, the next page, we start having word problems, okay, which we don't like. Let's see what we can do. 13. Show that there is no triangle satisfying the conditions A is 3, B is 10, alpha is 25.4 degrees. Okay, this is an impossible triangle. You cannot make a triangle that have these conditions. Now, how come? So A is 3, just start the problem like normal. B is 10, alpha 25.4. Okay, I can do law of sines because I have A and alpha. I have two of the same letter. Once you have two of the same letter, A and alpha, you can do law of sines. Right. So sine of alpha over A equals sine of beta over B. It is equal to sine of gamma over C, but I don't need to worry about that. Okay, I will first figure out beta. And then once you have beta, you have two angles, you can figure out the third angle, and then once you have that third angle, you can find the third side. Okay, so it looks like a normal problem. What's wrong with it? Just try it. Okay, so cross multiply. 3 sine of beta equals 10 sine of 25.4, right? So A is there, 3, B is there, 10, alpha goes there. Cross multiply, 3 sine of beta, 10 sine of 25.4, divided by 3. So sine of beta is whatever this is, and evidently it's 1.4 something. Let me actually show that to you. 10 sine 25.4 divided by 3. 10 sine of 25.45, 1.4 something. Impossible, right? Because we know the sine of any angle has to be stuck between -1 and 1. Sine of beta, sine of theta, sine of anything is between -1 and 1. We cannot get the sine of beta to be 1.429. So bottom line, such a triangle does not exist. You cannot make a triangle so that A is 3, B is 10, and this angle is 25.4. It's impossible to make such a thing. All right, next thing I'm going to go over is something called Huron's formula, but my version is different than the text, and I'm going to be mean to you. You have to do my version, okay? I guess you have to think of it from my standpoint as a teacher. I want to see everybody do the same formula. I don't want you to have half of you doing one formula, half of you do another formula, then I got to switch back and forth between what's happening. Obviously, when I'm grading your exams or quizzes, I want everybody to have the same formula, okay? So please do not use Huron's formula, page 270, as is. It's correct. There's nothing wrong with it. Our authors decided to use this version, which is not standard in most books. I'll give you the one that's listed in most books. So if you were to go on in more math, I'm assuming most of you have to move on to calculus and so on. And if you had to use the formula again, this is generally not the one that they would use. Here's the one that you would see. And this is the one that I want you to use. And this is the one I want you to put on your cheat sheet. Okay, how do you find the area of a triangle if you're given 3 sides? Okay, this is different. Okay, you might say, oh yeah, I know how to find the area of a triangle, 1/2 base times height. That's if you have base and height. You don't have a base and a height, but you do have all 3 sides, A, B, and C. So what's the area? Okay, so first we have to define something called the semi-perimeter. Okay, now you know what perimeter means. Perimeter means add up all the 3 sides, A plus B plus C. Semi means half. So A plus B plus C divided by 2. Okay, so first you figure out something called the semi-perimeter, A plus B plus C over 2. And now the formula for the area is the square root of S times S minus A, S minus B, S minus C, square root of the whole thing. So this is called Heron's formula. So you can have everything here. It may not be enough just to have this, because you put S, say, what does S mean? S is semi-perimeter. So I would say put all of this on your formula sheet. Okay, 3 sides. What's the area? First, you need the semi-perimeter, half the perimeter, A plus B plus C divided by 2. Add up the 3 sides, divided by 2. And by the way, a quick note, if you're typing it literally on your calculator, you should put parentheses here. Because if you type it exactly like this by order of operations, your calculator is going to think of it as A plus B plus C over 2. You want to take the whole thing divided by 2, so you should put parentheses here and here if you're actually doing it.
Can I ask a
Then
quick
here's the
question?
area. Okay, so the area is the square root of S times S minus A, S minus B, S minus C, and that'll give you the area. Yes, question.
When I was doing this problem, I just for a curiosity's sake, I tried to just use area equals 1/2 base times height. And I found the height by making a right triangle, in the middle, but it didn't work. Or maybe I did my math wrong, but I was just wondering if you could think of a reason why it didn't get the right answer.
It should work. It's clever that you thought of it that way. But if you bring this straight down and do the trig correctly, you would be able to find the height. In fact, the proof of this formula does involve actually getting the height. You'd have to do some cosine and sine stuff to figure out the height, and then it derives from this. Okay, so it should work.
Okay, all right. I guess
Definitely
that's
should
wrong.
work.
Okay, thank you.
Okay, you're welcome. Okay, but yeah, you don't actually have to go through that process to work out the area. Just go straight to this, and I'll give you an example of that right now, so you can see how it works. So let's see, 17. Find the area of the triangle with sides 12, 14, and 16. Okay, 12, 14, 16. So again, you say, why don't I just do 1/2 base times height? You don't have the height. You could do some trig to figure it out. You'd have to find one of the angles, right? Use a lot of cosines, and then based on that, do some more trig to figure out the height. But we have a new formula. So first I need the semi-perimeter. So add all these up, divide by 2, evidently it's 21. So let's see, 12 plus 14 is 26, plus 16 is 42. 42 divided by 2 is 21. And again, if you're typing it all at once in your calculator, you should go like this, 12 plus 14 plus 16 parentheses divided by 2. Okay, so see how I put parentheses around the whole thing? Whoops. So it adds up 12 plus 14, which is what, 26, plus 16 is 42. 42 divided by 2 is 21. Okay, a very common mistake that students would make is to go like this, 12 plus 14. See that? You get a different answer. Now, how come? If you stop and think about it from the computer or calculator standpoint, it says, oh, plus, divide, there's no parentheses. I will do order of operations. Order of operations says division is before addition. So the computer or calculator does 16 divided by 2 is 8 first, and then adds everything up. And you can see you get a different number. Okay, so if you're doing the whole thing in one fell swoop, put parentheses around the whole thing. Okay, now, how do I find the area of the whole thing? It goes square root of s, and then s minus each of the 3 sides. S minus a, s minus b, s minus c. So it's radical 21. And then you go 21 minus each of them. 21 minus 12, 21 minus 14, 21 minus 16. If you want to put this example on your cheat sheet, you may. And say, how do I get everything set up? Okay, so it goes square root of semi-perimeter, s, and then s minus each of the sides. So semi-perimeter minus 12, minus 14, minus 16. Okay, 21 minus 12 is 9, 21 minus 14 is 7, 21 minus 6 is 5. Okay, multiply them all together. So 21 times 9 times 7 times 5. 21 times 9 times 7 times 5 is 6615. That's underneath the square root. So hit my square root button, and I get 81.33 centimeters squared. Okay, so that's the area of this triangle. Okay, I'll show you one more that's like that. I know it's an even problem, but let me give you an example of how that works. Bigger numbers, 18. A triangle lot, 325, 175, and 200. Find the area. So it's going to be square feet. Okay, so here's the picture. 325, 175, and 200. Okay, now you might be saying, why don't I just do 1/2 base times height? Well, I don't know the height, right? You can use some trig to figure it out. It's going to be a lot of work. It can be done, but I think it's easier to just go with this. So find the semi-perimeter. Add all these up, divide by 2, 350 evidently. Let's see, that's going to be 500 plus 200, 700 divided by, 350. Remember, when you type it in your calculator, put parentheses here and here. Okay. Another thing you can do is add all these up first and then divide by 2. Okay. So you could optionally go like this, 325 plus 175 plus 200. See that? I added them up and then divide by 2. That's going to work. Okay. But if you try to type it all in one line and just put divided by 2 with no parentheses, that's not going to work because the calculator will only divide the 200 by 2 by order of operations, right? And ignore these. So if you're going to do it all in one line, then put parentheses and then divide it by 2. 350. That's called the semi-perimeter, half the perimeter. And then by formula, I take the square root of the semi-perimeter. And then I go 350 minus each of these guys. So 350 minus that, 350 minus that, 350 minus that. So 350 times 350 minus 325 is 25. 350 minus 175 is 175. 350 minus 200 is 150. Multiply this all up, you get this huge number. 350 times 25 times 175 times 150. Some super big number, 229,687,500, whatever. And then I take the square root of all that. So square root 15,155.44 square feet is the way that it works. Okay, and there we go. Okay, so I'm pretty much done, folks. So if you have any questions, I'll take them. Otherwise, we're finished. I will continue tomorrow. Next time, I'll show you 15. This is the hardest of all because there are two solutions. Solve for the missing parts of the triangle. Two solutions. That's the case where when you do the inverse sine thing, right? You have a first quadrant angle, but you might have a second quadrant angle. And the second quadrant angle also works. It does fit my quota of 180 degrees. So there's going to be two such triangles. Okay, so I was going to show you that tomorrow. And then go on and do some of these other word problems. Do some word problems at the end here. And then we're pretty much done with the chapter after that. Okay, so I'm finished for today. Anybody want to ask any questions? Otherwise, we'll quit. Let me check the chat. All right, I don't hear anything or see anything. So that's it for today, folks. All right, so we'll continue with this tomorrow and we'll see you next time. Okay, all right, bye, everybody.
Thank you.
Thank you.